Welcome to 10.1, where we'll talk about square root functions. This entire chapter is going to have square roots. We're going to start by graphing what it looks like when you have your variable underneath a radical sign. So I say graph, you say table. That's where we're going to start. And for today, you're going to do 5 values. Take my word for it this time. We're just going to start the table at 0. And then 1, 2, 3, 4. Do 5 values. And then you just plug those in for x. So the square root of 0 is 0, and 4 times 0 is 0. I can plot that. The square root of 1 is just 1, and 1 times 4 is 4. The square root of 2, I'm going to actually probably plug that in, is 1.4, and if I multiply that, that is 5.6. Oh, no, actually, if I round it, it's 5.7. And I can't really graph that very well. You know, I'm thinking maybe I should have gone by 2s. Let's try some 2s. So this should have been 1, 2, 4, and then 5.7. Okay. Plug in 3. The square root of 3 is 1.7. If I multiply that by 4, it is 6.9. So 2, 4, 6.9 is about right there. And last but not least, the square root of 4 is 2, and 2 times 4 is 8. 2, 4, 6, 8. So my graph is going to look something like that, which you notice does kind of look familiar to what we see up here. Let's try plugging in a -1 just for giggles. If I plug in a -1, try plugging square root -1 in your calculator. And I'll bet you get an error, right? Depending on what kind of calculator you're using, you're going to get some sort of error. And as we know, you can't have the square root of a negative number. The reason being, remember, a square root is asking what number times itself gives you that. Well, if you have a negative number, a negative times a negative is always going to give you a positive. And a positive times a positive is always going to give you a positive. There is no way to get a negative without having a positive times a negative to give you a negative number. And if you do that, you're not finding, it's not the same number multiplying, right? 4 and -4 are not the same thing. So that's why negatives under the radical sign won't work. And your graph will always point to the right unless there is some sort of negative sign that switches the graph. Now, the graph won't always start at 0, 0. Let's take a look at some of these. First of all, this first one is going down. And if you look at the equation, the thing that changes that is the negative sign. Okay, and on the next one, I noticed that it shifted up. It's starting up here at 1. Well, that's caused by this +1 right there. So as I look at the next one, I see the -2, and I think, oh, it should go down 2. But actually, it went right 2. Well, that's because this time that -2 was underneath the radical sign. So it turns out there's kind of a formula that can tell us what's going on, and that is the function of x or y, either way, equals positive or negative a, parentheses, oh no, I'm sorry, square root sign, x minus h, and then plus a k. So each of these has a specific purpose. The negative is going to flip the graph. Okay, just like it did over here. Then A is going to stretch or compress. It is stretched if A is bigger than 1 and compressed if A is less than 1. But notice that you should ignore the negative sign. So on this first example up here where it has -3, that should actually be flipped and stretched. Because I ignore the negative sign, 3 is bigger than 1, therefore it is stretched. H moves left and right. But as I see on that third example there, it's actually going to be opposite of what you think. and K is going to move up or down. Try and sneak that in there. Now here is, there we go, I'm highlighting those arrows so they're easier to see. Here's how you know where to start the table. You're actually going to start the table at the H value, remembering that the H value is actually opposite of what you think. So if I had to, like this first one up here, if I had to graph that on my own, my table, XY, would start at a positive 2, and then 3, 4, 5. Let's mentally check this out. If I plug in that 2, 2 minus 2 is 0. The square root of 0 is 0. Try plugging in a 1. 1 minus 2 is negative 1. Oh, can't take the square root of a negative 1. Okay, that's how you know where to start your table. Okay, so we can state some transformations. This 1/2, because it is less than 1, it would be compressed. Now I see that -1, I'm double checking. It is not underneath the radical sign. That makes it a K value, which means it moves it up or down exactly the way we think. So this one moves down 1. If I look at 5B, it is flipped. Okay, now is it stretched or compressed? If A is greater than 1, it's stretched. If it's less than 1, it's compressed. Once again, ignore the negative sign. So that means it is stretched. Now it has a -1. Double check. It is underneath the radical sign. That means it moves it left or right, but opposite of what you think. So since it's a -1, I think, oh, that would mean left, but opposite, so it actually moves right 1. And if I was going to graph the first one, there is no H value written. That means it must be 0. So I would start my table at 0. Whereas on 5B, the H value is opposite of what I think. It would be 1. And I would do my table from there. You can use these graphs to figure out a ton of different word problems. Here we have the Golden Gate Bridge, and we're looking for how fast an object is falling. Actually, I think we might do that one in person so we can see how that goes. Okay, it'll be a delta math where you have to move it around, figure out the A, H, and K value, play around with the values, see if you can move the graph around, and let me know if you have any questions.